Hi students, you are watching video series for grade 10 advanced physics, and in this video we are discussing chapter 1 lesson 3 wave behavior, and we will be discussing in detail pulse and wave, what's the difference between pulse and wave, incident and reflected wave, principle of superposition of waves, constructive and destructive superposition, then standing waves, waves in two dimension, and reflection and refraction of waves in two dimension. So let us start. I am Amir Shahjan. Welcome to Mass Academy. What is wave? We have discussed in the previous video, previous lesson. Wave is a disturbance. Wave is a disturbance that travels through a medium. Wave is a disturbance that travels through a medium to transport energy from one place to another without transporting the matter. So what is a pulse? Pulse is single disturbance. Pulse is single disturbance. Pulse is a single disturbance. For example, here we have a string here, and the string is fixed at both the ends. The string we have fixed at both the ends. So here we fixed the string, here also we fixed the string. So if I produce a pulse like this, if I plug this and release, so a disturbance, that is a disturbance, right? So if I just make one time like this, so that is a single disturbance. That single disturbance is pulse. So what is a wave? If I make this continuously like this, 1, 2, 3, 4, like that, if I am making like this continuously, so if I am producing continuous disturbance or a series of disturbance, so what is wave? Wave is a series of disturbance. Pulse is a single disturbance and wave is number of disturbance in series, right? So when I make one time, that is pulse. When I make like this continuously, that produce wave in the string. So I am producing a pulse like this, just making one time like this. So this pulse will be like this, right? If I make like this here. So this pulse will be traveling along the string like this. Pulse, after the next time this will reach here, the next time it will move, like the pulse will move along the string. So the next moment, the next instant, the pulse will reach here. So like that it travel along this direction. So this is traveling towards this end, right? So that is called incidenting wave or incidenting pulse. So this is the incidenting wave. So I will write incident wave. Incident wave. When this wave reach here, so this will travel and reach the other end of the string, right? So other end of the string, you can see here, this string is fixed, right? This end is fixed. Whenever a wave reaches a fixed point, then that will be reflected. So when this wave reach here, that wave will be reflected. It will be reflected. So it will be reflected and it will be going along the same line like this. It will reflect back along the same line. But I will draw that here, okay, as a second wave. If I draw, or I will draw like this. So this will be reflected. The reflected wave will be inverted. The reflected wave will be inverted, okay. So this wave is traveling like this, and when this wave go and hit this end, that wave will be reflected back. That pulse will be reflected back. When it is reflected back, it will be inverted. Before it was in the down, right? Now it will be like in the upside. When a wave is reflected from a fixed surface, from a rigid surface, the wave will be inverted, the reflected wave will be inverted. So this is our reflected wave. So you can note this point: when a wave, when a wave is reflected from a fixed surface or from a rigid point, rigid surface, from a rigid surface or rigid object or rigid point, from a rigid surface, the wave will be reflected. The wave will be reflected, and the reflected wave, reflected wave or reflected pulse, the reflected wave will be inverted. So this point you can note: whenever a wave travel and hit a fixed surface, the wave will be reflected and the reflected wave will be inverted. If the wave is going, if the pulse is like this downward, when it is go and hit this surface, because this surface is rigid, that surface is fixed, the wave will be reflected and the reflected wave will be inverted. You can see now the wave is upside. The next we are talking about principle of superposition of waves. Principle of superposition of waves. What is principle of superposition of waves? When two waves travel and reach at the same place at the same time, for example, a wave is coming like this and reaching here, another wave is coming like this and reaching here. When they reach a point at same time, then they combine together and to form and they become a single wave. They will become a single wave. That is called superposition of waves. Superposition means when two waves come and meet at a point, when they meet at a place, they combine together and they will become a single wave. That is called superposition. Then what is principle of superposition of waves? It states that the displacement in a medium produced by two or more waves is equal to the algebraic sum of the displacements produced by the individual waves. So what is principle of superposition of waves? The displacements in a medium produced by two or more waves is equal to the algebraic sum of the displacements produced by the individual waves. That is the definition for principle of superposition of waves. Now we will explain with the example. So what is principle of superposition of waves? It states that the displacement in a medium caused by two or more waves is equal to the algebraic sum of displacements caused by individual waves. the displacement in a medium caused by two or more waves is equal to the algebraic sum of displacements caused by individual waves. For example, here in water, okay, you are taking water in a bucket and you are producing a wave in that, and the amplitude of this wave, the amplitude of the wave you produced in that water in the bucket, that is equal to, for example, 2 centimeter. 2 centimeter is the amplitude of the wave that you produced in the water in the bucket, and your friend or your brother or your sister also producing wave in the same bucket of water in the same time. So she is producing a wave like this, and she is producing a wave with an amplitude of how much? We will take 1 centimeter. So both of you are producing waves in water in the bucket. You are producing a wave that is its amplitude is 2 centimeter, and your sister or your brother is producing wave in the same water in the same bucket, that is its amplitude is 1 centimeter at same time. So if it is at same time, there are two waves at same place, right? So they will combine together, and it will become a single wave. So here these two waves will combine to form a single wave that we call resultant wave. So here you can see the crest of this wave will add to the crest of the second wave, trough of this wave will add to the trough of the second wave, and the resultant wave means the product will be a wave with a greater amplitude. So what will be the amplitude of this wave? The amplitude of this wave will be algebraic sum of the amplitudes or the displacements of the individual waves. So its amplitude is 2 centimeter, its amplitude is 1 centimeter. So 2 centimeter and 1 centimeter, 2 plus 1 how much? 3 centimeter. So the amplitude of the resultant wave will be 3 centimeter. Amplitude of the resultant wave will be 3 centimeter. And this type of superposition is called constructive superposition. This type of superposition is called constructive superposition. So what is constructive superposition? In constructive superposition, when two waves meet, and when crest of one wave add to the crest of the other, or when crest of one wave meet the crest of the other wave, and the trough of the wave meet the trough of the other wave, then the amplitude of the resultant wave will be greater, or will be sum of these two waves. That is called constructive superposition. When two waves meet, one of the crest of one wave falls on the crest of the other. When two waves meet, as crest of one wave falls on the crest of the other, and trough of the one wave falls on the trough of the other, to become a single wave, then that resultant wave produced will have greater displacement or greater amplitude. That type of superposition is called constructive superposition. Another example. You are producing a wave in the water in the bucket as before, same as before, and the amplitude is 2 centimeter, and your sister also producing wave in the same bucket of water, and she is producing wave like this, okay, with an amplitude 1 centimeter. Here you can see when these two waves meet, they will meet, right? Because you and your sister producing waves in the same bucket at same time, same bucket of water at the same time, so they will meet. So when they meet, they become a one wave, right? They superpose, they will combine to become a single wave. So what will be the amplitude of the single wave? I know you will tell the answer like this. The amplitude of the single wave will be like this, right? The amplitude of the single wave, the amplitude of the resultant wave, right? The amplitude of the resultant wave produced will be like this, with a smaller amplitude, with a smaller displacement. So what will be the amplitude here? The amplitude will be equal to 1 centimeter. The amplitude will be equal to 1 centimeter. If I ask you why the amplitude is 1 centimeter, then you will say that here the displacement is downward, here the displacement is upward, so our amplitude is upward. So here amplitude is upward, so we will take it to positive. Here amplitude is downward, so we will take it negative. Then we add like this, 2 plus minus 1. So 2 plus minus 1 is equal to 1. So that is why the amplitude is 1. Like that you will tell. So that is perfect, that is correct. So here you can see, here when you add, you consider the direction, right? You check what is the direction. So if the direction is opposite, you are actually subtracting, and if the direction is same, you are adding the amplitude. So when you add, if you consider the direction, adding with considering the direction is called algebraic addition or algebraic sum. Algebraic sum means when you are adding, you are considering the direction also. If the direction is same, then you are adding. If the direction is opposite, you are subtracting. That is called algebraic addition or algebraic sum. So what is principle of superposition of waves? Principle of superposition of waves states that the displacement in a medium caused by two or more waves is equal to the algebraic sum of displacements caused by the individual waves. I hope you understand this. And this type of superposition is called what? This type of superposition is called destructive superposition. Destructive superposition. Why destructive? Because here the amplitude of the wave is decreased, right? The amplitude of the wave is decreased, or we can say half of the energy is decreased, right? So what is destructive superposition? When two waves meet at a point. When two waves meet at a point, as the crest of one wave add to the trough of the other. The crest of one wave add to the trough of the other, and the trough of the wave add to the crest of the other. Then the amplitude of the resultant wave produced will be less than the amplitude of the individual waves, will be less. That type of superposition is called destructive superposition. Destructive superposition. And if, one more example, if the wave your sister is producing, has same amplitude like your wave. This also has an amplitude of 2 centimeter. This also has an amplitude of 2 centimeter. So what will happen when they meet? They will combine, right? They will superpose to become a single wave. But what happens? So here you can see the amplitude is upward 2 centimeter plus 2. Here amplitude is downward 2 centimeter minus 2. So when they combine, the wave will be cancelled, right? The wave will be cancelled. So there is no resultant wave, no wave. This is like complete destruction, complete destructive superposition. Next we are talking about standing waves. Based on the motion of wave, we classify waves into progressive waves and standing waves. Till now we have explained or we have discussed about the progressive waves. We discussed about progressive waves. So what is the meaning of progressive waves? Progressive waves or waves, which means it travel from one place to another. A wave travel from one place to another to transport energy, so that is called progressive wave. Progressive wave means it is a traveling wave. It travels from one place to another. And what is the other type of wave? Other type of wave is called the standing waves. Standing waves is also called stationary waves. Stationary waves. So what is the meaning of standing waves? Standing waves means standing waves, the waves standing at a place. So the wave will store energy, it will not transmit energy. That wave, the standing waves, will not transport energy from one place to another. Standing waves will stand at a place so that it will store energy between 2 points. That is called standing waves. So how standing waves are produced? Standing waves are produced by the superposition. Standing waves are produced by the superposition of two waves. Standing waves are produced by superposition of two waves of equal frequency and amplitude moving in the opposite directions. So I will write like this how standing waves are produced. Standing waves are produced. Standing waves are produced by the superposition of two waves. Standing waves are produced by the superposition of two waves of same frequency. They must have same frequency and amplitude, and they must be and amplitude traveling. They must be traveling in opposite directions. Okay, for example, a wave is traveling like this, it reach here. Another wave is also traveling at same time and reaching here. If both waves have equal frequency and equal amplitude, when they meet at a point, so that they will superpose to become a single wave, and that single wave will not be moving anywhere, it will be at that place. Okay, that wave is called standing wave. So standing wave will not transport energy, standing wave will store energy. For example, I will erase this and I will draw how standing waves are produced in a string. Standing waves in a string. Okay, we will explain standing waves in a string. Standing waves produced in a string. Okay, so here we will take a string. That string is fixed here, and we will tie the other end of the string with another stand here, and I will produce a pulse here. A pulse, as we discussed before, the pulse will be transmitted and it will be reflected here. When it is reflected, the reflected pulse will be inverted, right? The reflected pulse will be inverted. So if I produce continuous pulses like this, a series of pulses, that is called waves, right? So that is that waves will be traveling from this end to the other end, and from here the waves will be reflected. So there are two waves, right? If I continuously produce waves like this, there will be two waves. One is the incidenting wave, right? That is moving along this direction. From here it is moving to the other end. So incidenting wave, right? Incidenting waves. And there will be reflected wave. Reflected wave will be traveling like this, right? So this incident wave, when it travel and hits the other end of the string, hits this stand, it will be reflected, and that wave is called reflected wave. So you can see here the incident wave will be traveling along this direction, and the reflected wave will be traveling in the opposite direction. As it is a reflected wave, that same wave is reflected, right? Same wave is reflected, so it will have same frequency and same amplitude, equal frequency and equal amplitude. So here we have two waves. One is the incident wave, other is a reflected wave. They have equal frequency and amplitude. They are traveling in the opposite direction. So when they combine, they produce standing waves or stationary waves. So we can draw the standing waves like this. We will draw the standing wave like this. So in this case, you can see here this one. At this point here, you can see the amplitude is maximum, right? Amplitude is maximum amplitude. And at this point, you can see here at the fixed end, amplitude is minimum, that I will note by the letter N. Zero amplitude, right? Here zero amplitude, zero displacement. The string is not moving, it is like tied there, so it is not moving. So here you can see here also the amplitude of the string is maximum, right? So it is moving like this, maximum up, maximum down, maximum up, maximum down. But here at this point the amplitude is again 0, that I will represent by the letter N. Here also the amplitude is 0, that I will represent by letter N. Here also amplitude is 0, letter N. So here the amplitude is maximum, I will represent by A. What does this A represent, or what does that N represent? N stands for node. N stands for node. So what are node? Node means points of zero displacement. Node means points of or positions of zero displacement, or I will write zero amplitude. Zero amplitude, that is called node. Why zero amplitude is produced? When two waves meet, why zero amplitude is produced? When two waves superpose together, that superposition. The result of superposition is called interference. And when two waves meet, why points of zero amplitude produced? Points of zero amplitude produced by destructive superposition. By destructive superposition. Superposition, another word for superposition is interference. So that is node. What are nodes in a standing waves? Nodes are points of zero amplitude. Nodes are points of zero amplitude. Why points of zero amplitudes or nodes are produced? Nodes are produced by the superposition of destructive, means produced by destructive superposition. You know that, right? What is superposition? When two waves meet at a point, they combine to become a single wave, and at some points the crust meet with the trough of the other wave. The crust fall on the trough of the other wave. Then the amplitude produced, the amplitude of the resultant wave will be a minimum. That is called destructive superposition. We have discussed already what is destructive superposition. Then what is this A represent? If N represent node, then A represent antinode, the opposite of node, right? Antinode. What is antinode? Points of maximum displacements. Antinode represent points or positions of maximum displacement, or maximum, I will write amplitude, maximum amplitude. Why these points of maximum amplitude produced, or how it is produced? It is produced by the constructive superposition. Constructive superposition. Constructive superposition. Then you can see how many nodes are here. Here you can see 1, 2, 3, 4. There are 4 nodes. How many antinodes here? 1, 2, 3. 3 antinodes. So the number of nodes will be always greater by 1 than number of antinodes in a string, in a standing wave in a string. So when a standing wave is produced in a string, the number of nodes will be greater by 1 than number of antinodes. If there are one antinode, if there is one antinode, then there will be 2 nodes. If there are 2 antinodes in a standing waves produced in a string, then there will be 3 nodes. So number of nodes will be always greater by 1 compared to the number of antinodes, and we will discuss standing waves in a string in detail in the next chapter in the physics of music. The next we are discussing about waves in 2 dimensions, and till now we have discussed about waves in 1 dimension. For example, you take a rope and you hold one end of the rope and you are shaking like this. You are moving your hand up and down. So you can see a waves in that rope. The waves will be like this, right? Like this waves will be in the rope. That is 1-dimensional wave. What is 2-dimensional wave? Did you ever see 2-dimensional wave? We always see 2-dimensional waves. For example, there is water in a pond, and the water is calm, completely calm, no movement in the water. And if I take a small stone and drop into that water, if I throw a small stone like this onto the water, so there will be waves produced in the water, right? There will be ripples produced in the water. What is the shape of that ripples? Shape of the ripples will be circular, right? So you will see like this waves, concentric circles, right? Concentric circles. The wave will be moving like this, right? The water surface will be moving like this. So you will see concentric circles, the ripples that we will draw like this. So this is the center where I am dropping the stone. So waves will be produced like this. We represent the surface waves or 2-dimensional waves by drawing concentric circles. What is the meaning of concentric circles? Circle, they have same center. Circles, they have same center. So this circle, each circle represent wave front. This is called wave front. What does wave represent in a 2-dimensional wave? What does wave front represent in a 2-dimensional wave? In a 2-dimensional wave, the wave front represent the crest. The wave front represent crest of the wave. First point, we represent a 2-dimensional wave by drawing circles, by drawing concentric circles. What does each circle called? Each circle called wavefront. Each circle is called wavefront. What does wavefront represent? Wavefront represent crest of the wave. So this is one crust, this is the other crust. So what is the distance between a crust and the adjacent crust? The distance between a crust and the nearby crust, that is called wavelength. That is called wavelength. Wavelength we represent by the letter lambda, the separation between two wavefronts. The separation between any two wavefronts represent lambda. The separation between any two wavefronts represent the wavelength of the wave lambda. And what is the direction of travel of the wave? So you can see here the wave will be traveling like this. Wave will be traveling along this direction. Wave will be traveling along this direction. So at each point, the direction of travel of the wave is perpendicular to the wavefront. At each point, the direction of travel of the wave is perpendicular to the wavefront. What did we discuss? Number one. In a two-dimensional wave, we represent two-dimensional waves by drawing concentric circle. What is the meaning of concentric circle? Concentric circle means circle with the same center. Concentric circle means circle with same center. Then what does each circle represent? What does each circle is called? Number 2, each circle is called wavefront. Each circle is called wavefront. Number 3, what does wavefront represent? Wavefront represent crust of the wave. Wavefront represent crust of the wave. Number 4, distance between two adjacent wavefront is equal to wavelength of the wave. Wavelength of the wave. Then last point, what is the direction? The direction of travel of wave is perpendicular to wavefronts. So these are the points you have to remember in two-dimensional waves. Now I will erase this and we will talk about the reflection in two-dimensional waves. Reflection in two-dimensional waves. So here we have a rigid surface. So this is a rigid surface. If it is light wave, so this is a mirror. And I will draw a normal here. Normal means perpendicular, like this angle is 90 degree, right? So this is our normal. So here I am just drawing a direction for the incident wave. So two-dimensional wave, it's a circular wave, right? So if I take a small part of that circular wavefront, that will be like a plane wave, right? So it will be like a plane wave like this. So we will draw the waves like this. So when it hits this rigid surface, when this wave hits the rigid surface, it will be reflected back. The wave will be reflected back. So the wave is reflected back along this direction. So the reflected wave I will draw like this here. So here this is the incidenting wave or incident wave, because incidenting onto that surface, and this is the reflected wave. This represent reflected wave because it is reflecting from the surface. And the red color line is the normal, right? This one is the normal. So this angle, that is the angle between incident wave and normal, is called angle of incidence I or theta I, and this angle, that is the angle between the normal and the reflected wave, that is angle of reflection R. So here law of reflection. What is law of reflection? Law of reflection states that these two angles will be equal. For example, if this angle is 30 degree, this will be also 30 degree. If this angle is 40 degree, this angle will be also 40 degree. That is what angle of incidence is equal to angle of reflection means. Law of reflection states that the angle of incidence. What is the meaning of angle of incidence? That I will tell. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Angle of incidence we will represent by I. So that is equal to angle of reflection R. Also in some books they will give angle I, like theta I and theta R, same thing. So in reflection or during reflection, you can see the angle of incidence. Angle of incidence means angle between incident wave and normal, that is this angle, that is the angle of incidence. And angle of reflection is angle between the reflected ray and normal, that is the angle of reflection. So in a reflection, angle of incidence will be always equal to angle of reflection. If this angle is 20 degree, then this angle will be also 20 degree. And another thing, during reflection, only the direction of the wave changes. During reflection, only the direction of wave changes. The speed of the wave will not change. The frequency of the wave will not change. Amplitude will not change. Wavelength will not change. So the separation between these two wavefronts, right, that is called wavelength. So the separation between the waves here and the waves here means the line separation between the lines must be same, because wavelength of the incidenting wave is equal to wavelength of the reflected wave. What did I say? I said the separation between means the distance between these two lines, because these two lines represent a wavefront. Each line represents a wavefront. So the distance between these two lines, that is wavelength lambda, right? Wavelength lambda. So during reflection, the wavelength of the wave is not changing. So that's why the reflected wave must have same separation between the lines. Next we will talk about the refraction. refraction of waves in 2 dimension. What is the meaning of refraction? Refraction means when wave travel from one medium to another, when wave travel from one medium to another, the speed and direction of the wave changes. That is called refraction of waves. When waves travel from one medium to another, the speed and direction of wave changes. That is called refraction of wave. Here we will take an example: water waves traveling from deep water to the shallow water. Waves traveling from the deep water to the shallow water. So here we have the boundary between the deep water and shallow water. So here we have the deep water, and here we have shallow water. What is this red color line represent? This red color line represents the boundary. So this one represents normal. This is boundary. Okay. So here we have water waves. So I will draw the direction of the incidenting wave. So we have waves like this incidenting here. So this is the wave incidenting to the boundary. So this wave we will call incident wave, and the angle between incident wave and normal, that we will call angle of incidence. And here the wave is traveling from deep water into shallow water. It is traveling from one medium to the another medium. So here the shallow water is more denser. As shallow water is more denser, this wave will bend towards the normal. It bent like this. It bent towards the normal, and the speed decreases, right? When the speed decreases, these waves will be, we have to draw closer. Why? Because when speed decreases, wavelength also decreases. When speed of the wave decreases, wavelength also decreases. So this is our refracted wave. And the angle between the refracted wave and normal, this angle, right? That is called angle of refraction, or So here you can see when I draw the separation, you see the separation here. The separation of the incidenting wave, the separation between the wavefronts of the incidenting wave, lambda, right? And the separation between the wavefronts of the refracted wave, lambda, you can see this lambda, this separation is less than the incident wave, right? Why? Because when speed decreases, the wavelength also decreases. So to show the wavelength is decreasing, we are drawing the line closer. We are drawing the wavefronts closer. Okay. So this is the end of the lesson, and I want to tell you, during refraction, speed changes, right? Speed will change. Direction of travel of the wave, direction also changes. Speed changes, direction also changes. Then what about wavelength? Whenever the speed change, wavelength will change. So what doesn't change? There is one thing that doesn't change, is the frequency. So during refraction, frequency of the wave, no change in frequency. You remember that. When wave travel from one medium to another, the speed, direction and wavelength changes, but the frequency of the frequency will not change. When speed decreases, wavelength will also decrease. If the speed increase, wavelength will also increase. So students, this is the end of the lesson 3, wave behavior in chapter 1. Thank you for watching this video.